Hello friends, so here is another question on electric charge and Coulomb's law. So the question is that the force between two electrons which are placed in air is equal to 0.5 times the weight of an electron. Find the distance between the separation gap or the distance between these two electrons. Okay, so here we have to make some put some data here. First, as the mass of electron and charge on an electron is involved, we have to write it specifically. The charge, electronic charge, E is equal to 1.6 into 10 to the power minus 19 Coulomb. That is the charge on an electron. It is negative, of course, but then mass of electron m subscript E is equal to 9.1 into 10 to the power minus 31 kg. Okay. Now acceleration due to gravity, G is equal to 9.8 meter per second square. So here it has been given that the force between two electrons, that is the force of repulsion between two electrons, is 0.5 times the weight of the electron. So here Fe is equal to 1 by 4 pi epsilon 0 2 electrons by r square, and this is the weight. The weight of the electron is equal to MEG. This is equal to 9 into 10 to the power 9 into 1.6 into 10 to the power minus 19 whole square by r square. This is equal to 9.1 into 10 to the power minus 31 into 9.8. So if we put these values in this equation, then it becomes 9 into 10 to the power 9 into 1.6 into 10 to the power minus 19 whole square by r square is equal to 9.1 into 10 to the power minus 31 into 9.8. That implies r square is equal to 9 into 10 to the power 9 into 1.6 power minus 19 whole square by 9.1 into 10 to the power minus 31. Sorry, this is 0.5 times. 0.5 times. See, I missed here. You don't make this mistake. It is very easy to make this mistake. You can miss this 0.5 part. It is very important. So here it is 0.5 into 9.1 into 10 to the power minus 31 into 9.8. That is r square. That implies r is equal to root over of this whole thing. Root over of this thing. Okay, root over of this thing. Okay, so r is the root over of this thing, and that will be equal to, if we calculate it, it is coming around 7.9 0.19 meter. This is the separation distance. Okay, so again this question is based on how well you remember the values, the value of the electronic charge, the mass of the electron, the acceleration due to gravity, because nothing is mentioned here. It is just given that the force between two electrons is this, so you have to remember the value of the charge on an electron, mass of the electron, acceleration due to gravity. If you remember these values, the values of these constant parameters, only then you can solve this question. It is very simple and straightforward. Simple application of Coulomb's law, and whether you remember the value of these constant parameters, weight of mass of electron, charge on electron, acceleration due to gravity, and all that. And another, like I just missed this 0.5 part here. I forgot to multiply this 0.5. Don't make that mistake. It is very easy because there are a lot of steps involved, so you can miss one or two things here and there, and the whole answer will be, solution will be wrong. So here be careful about that you include all the parameters. You don't miss that it is 0.5 times the weight of an electron. So that I missed here, 0.5 times. So I did that and we got the result. Okay, R is equal to 7.19 meter. Hello friends, so here is another question on electric charge and Coulomb's law. So the question is given as two identical spheres A and B. They carry a charge of 8 into 10 to the power minus 7 coulombs on each of them. A third similar sphere which carries no charge, okay, it carries no charge, sphere C, is first brought in contact with A and then in contact with B, and is finally separated from both of them. Now A and B, they are separated by 0.8 meters in air, the separation distance. We have to find the force of repulsion between A and B. Okay, so again this question is based on how charges, they get divided between identical spheres, the sharing of charges. So first let us try to understand the question. So we have first two spheres, okay, sphere A and sphere B. Okay, both of them carry a charge of, let's say, small q. We will denote it as small q, which is 8 to the power 10, 8 into 10 to the power minus 7 coulombs. That is the charge on A and B. Okay, QA equals to QB equals to Q, which is this much. Now we have a third sphere, okay, a third sphere which is first brought in contact with A, okay. This third sphere is C. It carries 0 coulomb of charge. It is brought in contact with first A, okay, it is brought in contact with A. So let us take this two charges, the contact between A and C. Initially charge on A is Q, okay, which is this. For now you just take it as Q. Charge on C is 0. This is Q coulomb, this is 0 coulomb. Total charge, net charge is Q plus 0 coulomb, which is equal to Q coulomb. Now since these two spheres, they are identical, but C carries no charge, but they are identical, so charge will be shared equally. So charge on QA and QC after contact is equal to the total charge Q divided by 2, Q2 coulomb, okay, QA and QC. So now the charge on A, okay, the charge on A after contact is this much, Q by 2 Coulomb. After contact it is Q by 2 Coulomb. Okay, now after bringing in contact with A, charge C is then brought in contact with B. Okay, charge C is brought in contact with B. Now here charge on B is equal to Q Coulomb. Charge on C after bringing it in contact with A, and after all that, charge on C is Q by 2 Coulomb, which it acquired through sharing with A. Okay, this QA and QC, Q by 2 Coulomb. So the total charge during contact is the net charge, or the total charge, Q plus Q by 2 coulombs, which is equal to 3Q by 2 Coulomb. Now since charge B and C, they are also similar, they are identical, so they will also share the charges equally. Okay, so the charge on B and C after contact between B and C is, okay, after contact is 1/2 of this, which is equal to 3Q by 4 Coulomb. So now charge on B, finally charge on sphere B after all the contact and everything is 3Q by 4 Coulomb. Now it has been given that after all of this, charge A and charge B, they are separated by 0.8 meter, 0.8 meter, okay, they are separated by 0.8 meter. So this is Q by 2, this is 3Q by 4. Now the electrostatic force of repulsion, as they are both positive, though they will repel each other, so that repulsion force is equal to 1 by 4 pi epsilon 0 QA and QB after contact by R square. So that is equal to 9 into 10 to the power 9 multiplied with, we'll replace Q with this value, 8 into 10 to the power minus 7 Coulomb. So for QA it is 1 by 2 into 8 into 10 to the power minus 7, and QB it is 3 by 4 into 8 into 10 to the power minus 7 by R square, which is 0.8 whole square. Okay, this. So the result finally, if we calculate it, I am using a calculator here for quick calculation. So the result that we are getting out of this is 9 into 10 to the power 9 by 2. Okay, this is 2, this is 6, 0.8 square. Okay, it is coming around 3.375 into 10 to the power minus 3 Newton. That is the force of repulsion. This. Okay, so this question was based on two things. First, the concept of sharing of charges between identical spheres or identical objects after contact. That is the first. Second thing is basic Coulomb's law application. Okay, so you have to be familiar with these two concepts in order to solve this question, and this is the answer here.